Hi, that we continue the 7.3 two-way analysis of variance, but now that we extend the model a little bit. So I introduced the notion of interaction. So the model 5, that is the original, the two-way ANOVA, xij is equal to mu plus alpha I plus beta j plus epsilon ij, is based on a strong assumption that the volume of passengers that was xij is a linear function of year. Year is the first factor, I, and the month. So the year and month does not relate to each other. So that is that we assume that the seasonal pattern is the same for all years. But if such an assumption does not hold, for example, the different year have the different seasonal patterns, then we have to think about more flexible model. So that is xij is equal to mu plus alpha ij plus beta j, alpha I plus beta j plus the gamma ij plus epsilon ij. So gamma ij is introduced. And we need some restriction on gamma ij anyway, because when we introduce the alpha I, that we have to set either alpha I is equal to 0 or a summation of alpha I is equal to 0 to avoid the redundant parameters. And we have to do something similar for gamma ij, but we can include this gamma ij to consider the interaction between the first factor and the second factor. For example, for maybe some agricultural data, maybe some fertilizer that only works for maybe the south exposure of the crop, or maybe some fertilizer works only if the weather is cold. So in such a case, we have to consider the interaction. But obviously, this model does not work if we don't have enough observations. So in the last example, that we have I is equal to 1 to maybe capital I, and j is equal to 1 to capital J, and we assumed that there is only one observation for each pair of ij. So in such a case, so this model is basically the same as xij is equal to mu sub ij plus epsilon ij. So if we drop all conditions on alpha I and beta j and the gamma ij. But this does not work, because if we estimate this model with just the ij observations for which each pair of ij that appears once, then that becomes just mu ij hat is equal to xij, and epsilon ij hat is equal to 0. So basically, these have the I times j parameters, and we have I times j observations, so we can explain everything. But this model that makes sense if we have multiple observations for each pair of the factors. For example, we have year and month, but suppose that we have the 2 countries or 3 countries, then we have observation for maybe 2 or 3 observations for year and month, or maybe we have the 50 states. So 50 times the number of year times number of months observations, then it's totally reasonable to fit this model, because this model can be written as xijk is equal to mu ij plus epsilon ijk. So k is equal to 1 to I sub ij. This may depends on the pair of ij. And then we can estimate mu sub ij and also maybe the size of error, so the variance of epsilon. So this is the so-called the repeated measurements model. So now that we discussed how to see whether or not we have interaction. So interaction plot is the convenient way to do this. And the interaction dot plot function, so we have the first factor as the first argument and the second factor as the second argument, and this is the response, xij. Then the graph becomes this. So at first, the first factor is here, and the second factor is here. and this is the response. So you can see, so first factor and second factor are related or not by seeing these patterns. So you can see that these patterns are very similar for all years. These patterns are almost the same. So that means the month and the year have different effects. So if the graph that looks like this for some years, then obviously that we have some relationship between the seasonal pattern and the year. So we have to consider the interaction, but here that we don't have such curve, and all curves are similar. So in this case, we can assume that the interaction term is negligible, so we can ignore that. Yeah, so the two-way layout with interaction is like this. So that we think about a simple case that we have I is equal to 1 to m, and j is equal to 1 to n, and k is equal to 1 to q, and that we have, so each pair of treatment ij, has the q repeated measurements. For example, the fertilizer and the sun exposure is the I and j, and the k is just the repeat. So we have maybe q plants for each pair of the condition, the fertilizer and the exposure, sun exposure. Then we can fit the model. The xijk is equal to mu plus alpha I plus beta j plus gamma ij plus epsilon ijk. And epsilon ijk is just IID, normal 0 sigma square. So this is the basic two-way layout with interaction. And we need restriction of summation of alpha I is equal to 0 that we have seen in one-way ANOVA also. And the summation of beta j is equal to 0. So basically this is because we have the baseline level. So we have parameter mu. And also that we need the summation of I of gamma ij is equal to 0, and the summation j of gamma ij is equal to 0 for each I and for each j for the previous one. So in short, we have so think about the number of parameters. So one parameter here, and here the m parameters, and here n parameters, and here m times n parameters. But in total, we have the m times n pairs. So in total, there should be m times n parameters. So this parameterization is redundant because in total, we have 1 plus m plus n plus mn. So actually, we have the 1 plus m plus n redundant parameters. And one possible way is to drop mu alpha I and beta j. But these are basically the primary factors in terms of the statistical estimation. So the effect of the first factor and the effect of the second factor are more important than interaction. So we don't want to abandon alpha I and beta j. And the two, to solve this problem, that we assume the one restriction here, for example, summation of alpha I is equal to 0, or alpha 1 is equal to 0. And one parameter here, or maybe we should use the red for the number of parameters, 1 and 1. And so we have two restrictions, but still, in total, we need the 1 plus m plus n restrictions. So now that we have here, the summation of gamma ij is equal to 0. Summation I over I of gamma ij is equal to 0 for each j. So j is equal to 1 to n. So we have n restrictions here. And here that we have m restrictions. And actually these restrictions that have the one redundancy, you can see that the summation of summation I gamma ij is equal to 0 for all j, and the summation j gamma ij is equal to 0 for all I. But both equation can lead to the summation of all gamma ij is equal to 0. So actually there's one redundancy here. So we have to put -1 here. So in total, we have the 1 plus n plus m minus 1. So m plus n plus 1 restrictions. So we can estimate this model correctly. Yeah, so this way, the two-way layout with interaction works.